and good morning. Right now, maybe yesterday and last Wednesday, we had our paper one. Okay, paper one and paper two. So then all praise to God. Okay, this the most of the things whatever I have predicted came to exam. Okay, so still they are releasing certain videos. Okay, last minute, just we predicted lots of stuffs. So even essay paper and also the MCQ paper. Like most of the things, whatever we have done in the last minute, whenever we recall it in the last minute, right? All came to the paper. Okay, so we will upload that in our channel. Now, first of all, I have given you certain questions to do because our first target is, this year A levels chemistry paper was not that hard. Okay, it was a shape paper, but unfortunately, the paper is not balanced. Even when you take the MCQ paper, it is not balanced. The calculation questions what they have asked in the paper also, like it was easy. Some students they say like, what did now you'd have asked from your seniors. Now, what did they tell about the chemistry paper? Difficult about the chemistry MCQ paper. What is the opinion? You can put it in the chat box. What did they tell? Your own people, whoever. We'll speak because we'll go this with as a discussion session, right? Not only like a teaching one, okay? Because here you have to argue, you have to speak, then only you can improve your knowledge. Alright. Therefore, did you speak with your seniors who have done the paper? What did they tell? What is their opinion about the paper? Yeah, what's their opinion? You can type, everyone type in the chat box. Okay, this is their opinion, something like that. Yeah, no one asked from your seniors, how was the paper? Now they are writing at the moment. They are writing the general knowledge paper, right? Right. Then what they told was because after every paper we asked from our students, right? How was the paper? So according to this one, even the bio paper they told was difficult. Maths paper was difficult. Bio MCQ was difficult, and the bio this time what is the structure they say they have asked is also in a different way, like not the same way. Directly they haven't asked the questions. You have to creatively answer the questions they have asked like that. Plus, this one, that's about the bio paper. Maths paper, bio was okay, but applied they have asked in a different concept. Yeah, concept the same, but the question modules, the way how they have asked is different. But finally, they had the chemistry paper. The chemistry papers, okay. This one, MCQ. Again, MCQ. Well, this time they have asked more graphs. Are more graphs. But I did almost like I trained them for all the graphs in the last book. But again, just 9 days before the exam, I told there's a high chance of asking the graphs. So I trained them for the graphs. So whatever we trained, alhamdulillah, it came in the paper. Right. So still we have uploaded only two videos, whatever have come. I think slowly we'll upload one by one, even they say paper stuffs. And even there are so many industries. Alhamdulillah, whatever the industries we predicted and before the exam itself, I told them, right, definitely there will be a sodium hydroxide industry will come as a flow chart. So, yes, I felt whatever we feel, we just tell it what mostly most those things came. So the same thing came like that, and also you will get those. I will put that. Hari, I think anyhow, now they're done with the exam. But do you think all are happy after the exam? You think like at least they will have some relaxation, a temporary relaxation, right? That they have completed their exam KL at the moment. But that's temporary. Again, whoever done really well, that will be permanent. So when the results released, still they will be in that happy state. But temporarily now people will be happy. Oh, I have done the paper now. Will now we are free. Again, they will feel. But still, once the results come, like December, when the results come, what will happen? At that time, they will regret. So that temporary happiness will end. Okay. So, what is the lesson I have to give you from this experience of 2026 A level students? Okay. The experience that I wanted to give you is, okay, from their experience, what I wanted to tell you as a teacher, right? Main thing, guys. Okay. Now, everyone tell what is the problem when they face the exam? Okay. What is the difficulties when they face the exam? Okay. What are the difficulties? Main thing everyone told they couldn't manage all three subjects from the beginning. So most of them now they have decided to do second shy, right? Most of them they have decided to the second shy. Why? Because they understood, right, the mistakes what they have done, and now they want to try it harder. Because actually there is a big difference between the first shy and second shy. Because first shy students do mistake. Okay, the main mistake is they don't balance all three subjects, right? So you guys are freshers. So okay, you guys are freshers. So what I wanted to tell you is only one advice. If you don't balance all three subjects, right? This is about balancing the subject. Okay, balancing and doing your work. Okay, that's why A level is not easy. Okay, although you know the content, you can't answer that. Okay, you should have a stamina. Okay, when you face a paper, guys, there is a thing called stamina. You should have that stamina to face that paper, because when you see a difficult question, you should know uh, to balance it and to face it. Okay, so if you balance and face it, what will happen? You will get the chance. You will get an ability, all right, to answer the questions. Papers, don't think A-level papers won't be easy. Some students asking, so this time difficult, nang, next time will it be easy? Because this is a competitive exam. Enisa, they will never make the papers easy. Arey, එහෙම කරන්නේ නැහැ. The papers won't be easy. Every year it will be difficult. If there will be some easy questions, there will be very difficult questions, right? So it's a mixture actually. Now, if you want to be ahead of everyone, the main thing, okay, that's the main thing, okay, balance. Always remember management of all three subjects very well. Okay. So this is the advice I just wanted to give you, because now they're done with the paper yesterday. Okay. So what they everyone almost spoke like they told about the current scenario. Okay. So we'll see what you're going to do. Okay. So although you're first shy guys, right? If you can balance things, you can go for a very massive research. Okay. Very good research. Okay. Now let's discuss mainly. That's why I said that's why this mainly this past paper discussion. Okay, apart from the class, mainly this past paper discussion to keep you ahead from everything. Right. Now let's go. Now, first one. Now I have given certain numbers, right? I told complete these questions, Kela, because still we have completed in our theory class only 2 units. Okay, so we have to start the third unit. Our first term will be from unit 1, 2, 3. Alright. So 3 units will be there. Still, now only you started school, but still, okay, we have to train you for the exams. Right. Past papers, however, we will do in the class itself, in the theory class itself. Mainly here, other papers, model papers, and some. So this is FWC paper, right? Okay. Now let's discuss this. So first one, the scientists who proposed the principle about the atomic structure, who contribute to the least. Okay, I think I gave this question in a paper. Alright? Same one, same thing. Okay, so you know what Rutherford did? Okay, now here this is a discussion. Okay, I would appreciate if you could unmute and speak. Someone. Okay, how Rutherford contributed. No, you can take this paper as a printout. Okay, so you keep a separate book for this. Okay, so you can write it separately. Okay, so you can take a printout and you can keep this. So if we're going to exam, you can check all these stuffs. Okay, so what did Rutherford do? Rutherford, again, you have to write everything. Okay, Rutherford, what is Rutherford only? He only did the gold foil experiment. Using the gold foil experiment, okay, using the gold foil experiment, he found the nucleus. There is a proton, there is a positively charged nucleus. That is proton scalar. Rutherford only found. Okay. So atomic structure nucleus is an important part. So Rutherford contributed for that. Thomson, J.J. Thomson, he only found the electron. Okay, he only found the electron. So you know electron is a very important part in the atomic structure. So Thomson, he found the electron. Niels Bohr, he said he only gave the idea electrons are rotating around the nucleus. Okay. Then he rotate around the nucleus. He said. Dalton, what he said, he only first introduced the atomic model. Okay, first introduced the atomic model, but all the things that he said became false. Okay, so next one is Marsden. He also contributed in the gold foil experiment to find the positive charge, the nucleus, right? But Rutherford, we are telling Rutherford who found that. Okay, right. Then good. So answer is Dalton Vidyarthama. We have to go here, but all contributed. Least contribution came from Dalton. Okay. Second one. Which of the following statement is false regarding the Lewis structure of ClO3 minus ion? Now, how you should draw the Lewis structure? You know, this is a third period element. Now, I gave Lewis structures under 4 categories. How to draw Lewis structures? I trained you very easy patterns. How to draw Lewis structure for second period, how to draw Lewis structure for a third period, how to draw Lewis structure for oxyanions in third period, and special structure scalar. I told about NO and NO2. Okay, these are the structures you should know mainly. So this is a third period central atom. Okay, how to say that third period is a central atom? Because there are 3 oxygens and definitely chlorine should be the central atom. Anyhow, when you have beyond third period, central atom is decided by the atom, the central atom, whatever the atom in the middle is known as the central atom. Okay, whoever having the least electronegative atom. Right now, we'll say chlorine and oxygen is there. Out of this, who is least electronegative? You should know the electronegativity of the element, how it goes from left to right. You know, electronegativity increases. From left to right, electronegativity increases. And when you're going down the group, electronegativity decreases. Okay, electronegativity decreases down the group. Here, electronegativity increases. Okay, across the period. This side, electronegativity increases. Here, electronegativity decreases. Okay, so we said the highest electronegative elements. You should know this because they asked this. Highest electronegative elements, you can remember FON, okay, Cl, Br, INS. Okay, remember these are the highest electronegative element. So you can remember this one as phone colored brought ice cream dinner sister, right? This phone colored, Cl means colored, bro means Br, ice cream means I, sister means sister, ice cream dinner sister. Right? So phone colored brought ice cream dinner sister. When this one only okay. This one is the thing what you can do. The next one, which of the following statement is false regarding the Lewis structure of ClO3 minus ion? Then using this, you write whatever necessary things, okay? And chlorine, you have to give the central atom. Now, this is known as the oxyanion. Oxyanion. What do you mean by oxyanion? Oxyanion mean a minus charge ion with oxygen. That is oxyanion. So if there are oxyanions, remember guys, the minus charge that will be on the oxygen. Okay, that will be on the oxygen. So if I put the oxygen here, right? If I mark the oxygen here, right? If I mark the oxygen here, you have to put the minus charge on the oxygen. Okay. If you put a minus charge on oxygen, that oxygen should bond with single bond. Now the other oxygen you connect to this according to their valency. Now you know oxygen's valency is 2. So oxygen valency is 2 mean children, you connect this oxygen with 2 bonds like this. So other 2 oxygen will connect like this. So this will be the ClO3 minus ions Lewis structure. Then count the number of electrons around the atoms. 1, 2, this 3, 4, 5, 6. Here 1, 2, 3, 4, 5, 6. Here 1. Then because of the minus charge, what will happen? Why we put a minus charge actually? Because if they make the number of bonds less than their valency, like if they make the number of bonds less than their valency, they get a minus charge. So here there is only one bond, mean here there will be a minus charge and connected with 6 electrons like this. So altogether there will be 7 electrons around this oxygen. Why? Normally, you know, oxygen is 16 grouped element. So around oxygen there should be only 6 electrons. With this minus charge, they will get 7 electrons. Why you get a minus charge on that? Because they are getting an electron. That's why it's getting a minus charge. So there should be 7 electrons around this oxygen. Okay. Then this also an electron here. Then you can count and see how many electrons are here. Sorry. So around the chlorine, there should be 7 electrons because it belongs to 17 group. Chlorine belongs to 17th group. So there should be 7 electrons. So 1, 2, 3, 4, 5, 6, 7 kilo we can mark. So there are 7 electrons like this. Now children, okay, you can say number 1, trigonal pyramidal relative to the central atom. Okay, is it trigonal pyramidal? Yes. Okay, this is known as trigonal pyramidal according to VSCPR units. Okay, if you haven't done that, you want to understand this. Anyhow, VSCPR mean valential electron pair repulsion units. So there are 4 units here. 1, 2, 3, 3 sigma bonds and 1 lone pair. So 3 sigma bonds and 1 lone pair mean it's trigonal pyramidal mean that is true. Can draw equally stable 3 resonance structures. Yeah, you can draw equally stable 3 resonance structures. Why? You can change this oxygen minus charge for this oxygen, this oxygen. So likewise, you can draw 3 structures. So that is true. So all CO bond lengths are equal. That is also true. I have told you when I'm teaching this, right? If you have any oxyanions, guys, if you have any oxyanions, right? Remember, any oxyanions, the bond length are equal. Okay. Before they're going to make a bond, when they are as oxyanion. Okay. Now we'll say now the ClO3 minus ion, we'll say they form now ClO3 minus is like this. No. Now just imagine a hydrogen comes and join here. Okay. Here mainly we have to understand what are the other questions also. The future questions what they can ask from this. We'll just imagine when hydrogen bonded for these guys. Again now they can make resonance structures with this. Therefore, what will happen? Now all the ClO bonds won't be equal now because they can't make resonance structures. Okay. But before connecting this hydrogen, when they as a anion, when they as a minus charge, what can happen here? Okay. What is resonance structures? They can shift the bonds. They can shift the pi bonds. You know, when there are 2 bonds, okay, it's like sigma bond and pi bond, right? So in the method, I can erase this. Then I can put it here. This pi bond, I can put it here. When I'm putting the pi bond here, the minus charge will shift here. So this is another resonance structure. These are only known as resonance structures. Okay, 2 electrons will come here. 2 electrons will go from here. All right. So this is another resonance structure. Same thing, I can shift the minus charge and the single bond for this oxygen. All right. Likewise, I can keep on shifting. Right. Now, the next thing is, guys, right? So all ClO bond lengths are equal, Kiyaneka. So I have to say that is true now. Okay. In all resonance structures, the oxidation state of central atom is +5. Okay, how to see oxidation state? Okay, because you guys are freshers, that's why I'm taking time and I'm explaining every single thing. Hari? How to see the oxidation state, oxidation number, right? We say oxidation state, oxidation number, kila we say. How you say when you take a bond, children, right? When you take a bond, children, now these are bonded, these are bonds. These lines are representing the bonds. So this oxygen and chlorine connected with a bond mean. Now you have to say which one is more electronegative. Now when you take chlorine and oxygen, Which one is no most electronegative? Already I told a pattern of FON, FON, when they make. Already I told these are the highest electronegative people. Phone color. Now you can see oxygen is more electronegative than chlorine. Therefore, in this bond, now we are marking the relative charges. Relative mean how we mark relative. When one is -1 mean other one become +1. That is only known as relative. Okay. So we will say in this bond, because oxygen is more electronegative, more electron will come towards oxygen. Therefore, oxygen we are marking the charges -1 charge. Chlorine will get a +1 charge here in this bond. So we are marking like that. So here there are two bonds, no children. Since there are two bonds, okay, because of one bond oxygen will get 1 minus charge. Because of two bonds oxygen will get 2 minus charge. And so this oxygen will get a -2 charge. Because of this -2 charge, this chlorine will get a +2 charge. Same thing for this oxygen also. Because of this oxygen will get a -2 charge. This chlorine will get a +2 charge. Okay, now what you have to do, add all these things. So when you add all these things, what will happen? +2 +2 +4 +4 and 1 +5. Okay, +5 means what will happen? That is the answer is true. Okay, is +5 means that is true statement. Okay, now the fifth one of these bonds can be identified as a dative bond. What do you mean by dative bond? Dative bond mean, when you're sharing again out of covalent bonds. Covalent bond means sharing electrons. Ne? So in the covalent bond, children, if one atom, if the same atom donate both the electrons, mean that is a dative bond. For an example, I can give you an example. Ammonium plus. This ammonium plus, they have a dative bond. How they will get a dative bond? Like this. Now you have ammonia. Ammonia is like this. Just will draw ammonia like this. NH3. For this NH3, children, you can now learn. Can if you have missed these areas, now even a student if you don't have any knowledge, still you can understand from this. Now when you take ammonia, this ammonia has two lone pairs like this. Okay, two lone pairs. Now this one is a H plus ion. This is a H plus ion. So H plus ion means what? Hydrogen is having one electron. So in the H plus ion, what will happen? Even they will lose that electron. Okay, H plus ion, even they will lose that electron. එතකොට now H plus is a person without electron. Ammonia is having two electrons. Now they are inviting H plus. Ade machan come, will make a bond කියලා. But H plus is telling, ade I don't have electrons. Then ammonia is telling, no worries. I got two electrons. I will give both. We'll share both of them කියලා. Ammonia making a bond with H plus. So we mark that with an arrow like this. So after giving these two electrons, they will make a bond like this. Okay, NH4 plus scalar. So 4 hydrogen will connect around now ammonia, right? And this nitrogen will have a plus charge on this now. Because why nitrogen will have a plus charge? Because nitrogen is donating the electron. Give me a minute, guys. Right. Okay. I'm sorry. Now, so you can write a note under this, right? So under these questions, you can write. Okay. Dative covalent bond is a bond which is donated, which is shared electron by the same atom. Okay. It's a bond where electrons are shared by the same atom. Okay. So after forming the dative covalent bond, okay, after forming the dative covalent bond, you can't identify which one is dative covalent bond. All are considered as normal covalent bond. Okay. Uh, Now you don't have a dative covalent bond in ClO3 minus because nothing is happening like this, because here all the electrons are shared by both the atoms. Oxygen is giving one, chlorine is giving one. There is another name for dative bond. Can someone tell? There is another name. Can you tell another name for dative covalent bond? There is another name, children. What is the name given for dative covalent bond? Yeah, who can tell? I appreciate if you could unmute and speak, children. Okay, I have given you the chance to speak or at least chat box. You can use the chat box. What is the other name given for dative covalent bond? Very good. Coordinate bond. Excellent. Okay, coordinate bonds. Okay, that is known as coordinate bonds. Nice. Okay, so mark these things. Okay, because MCQs normally discussion will take a long time because we have to explain each and every statement, why it is correct and why it is wrong. Okay, next. Now, the next one. We'll go for the third one. They have given a this one here E, and there are two fluorines and one oxygen with 2 minus charge. Okay. So can you tell me which group does E belongs? Did you select that? If you have selected, can you put in the chat box what you selected? Because I just wanted to know whether you selected it correctly. Because I gave you this question today morning around 6 o'clock. I sent these questions. Do this scalar. Anyhow, can someone, please, everyone, please send your answers what you have marked for this? For E, which group? Group 5. Again, that option is fifth option, is it? Group 4. Group 5. A group number. Okay, group number. Okay. Group 6. Group 7. Okay. Okay. Good. There are so many answers. Group 7. And okay. Fifth option. In group 8. Right. Now let's see how can we decide this. What is the group? Okay. It's a nice question. Okay. Right. Let's see which one will be the correct one. Now, children, what is this outer? What is this charge? This charge is the entire entire compound's charge, the total charge of the compound. That is only known as 2 minus charge. Okay, that is only known as 2 minus charge. Okay, that is I'm sorry. That is only known as 2 minus charge. What do you mean by 2 minus? 2 minus mean they have gained 2 electrons. That's the meaning of 2 minus charge. Now, you can see E is the unknown compound, but this F mean fluorine, this F mean fluorine, this O mean oxygen. Now, I told you, how to decide charges. How we decide charges? According to their valency. Now, what is oxygen's valency? Oxygen's valency, it is 2. Fluorine belong to 17th group, so fluorine's valency is 1. Okay, fluorine's valency is 1. From O level itself, it goes like 1, 2, 3, 4, 3, 2, 1. It goes with the group, right? So, oxygen's valency is 2, fluorine's valency is 1. So, but oxygen has only one bond here. I told you if the number of bonds are equal to the valency, charge will be 0. If the number of bonds are less than the valency, mean they get the minus charge. So this oxygen should have a minus charge. But this entire complex has 2 minus charges. It means now fluorine can't have a minus charge no? Because it is however connected with one bond, that is fine. Fluorine are neutral. No? Then the other minus charge should be on this E. Then we have to put the other minus charge on E. Then only we get 2 minus charge on this entire compound. Everyone understood that point? No? Yes, right? Okay, if you have any misunderstanding, you can ask. Hi. I'm sorry. Now, Puta, if there is a minus charge, what does it mean? Now, around this E, how many electrons can count? 1. Count the number of electrons around this E. 1. In this bond, this is 1 electron belong to in. 2, 3, 4, 5, 6, 7. There are 7 electrons. Out of this, how many electrons are actually owned by E? There are 7 electrons. Put it in the chat box. There are 7 electrons. Out of these 7 electrons, if E is having a minus charge on it, actually how many electrons are owned by E? It's supposed to be? Right, very good. It should be 6 electrons. Right, it should be 6 electrons. Because of the minus charge only, it is getting the 7th electron. E is actually having 6 electrons because of the minus charge what it is having on E. That's why it has got a 7th electron. Therefore, if it is an element in the valence shell, there are 6 electrons now. It should belong to which group? 6th group, right? It should belong to 6th group. So answer is 6th group. Did you understand how I selected this? Raise your hand if you understood this part. No, you go, okay, understood. Right, good. If you have a problem, you ask. Huh? This how we have to do. Again, if you have a problem, you can ask, so why it is like this, why it is like this. Okay. Right. But explain the last part once again. I'll tell again, careful listen. Now, first of all, there is a 2 minus charge, no, Putra. This 2 minus charge belongs to what? To the entire compound. This again, this is in the total compound, there are 2 minus charges. Now, first thing what I told, see the outer atoms, whether they are neutral charge or a minus charge element. Okay. Now, fluorine is what? Now, fluorine's valency is 1, oxygen valency is 2. How we decide whether they have a charge or not? With their valency. So, fluorine's valency is 1, means fluorine connected to one bond now, they are neutral charge. If the valency and number of bonds are both are equal value now, equal values means that is neutral charge. But the number of bonds and valencies are different, different means, right? For an example, now see oxygen's valency is 2. This oxygen valency is 1. So this oxygen should get a minus charge. If this entire compound get 2 minus charge means, definitely the other minus charge should be on this E, because fluorines are neutral. So if it on E mean, check the number of electrons around E. 1, 2, 3, 4, 5, 6, 7. There are 7 electrons. But these 7, how did these 7 electrons came here? Because of this minus charge. What do you mean by minus? Minus means he has obtained 1 electron from outer side. Okay, from any he has obtained 1 electron from outer side. Okay, so he has obtained 1 electron. Actually, he had how many electrons? 6 electrons. Therefore, he is having 6 electrons in the outer shell. Therefore, he should belongs to group 6. Okay, because outer electrons decide the groups. If there are 6 electrons, now he is group 6. Clear? Right, good. Now, that how you select this group. Okay, very nice question from here. Hare. Now they have asked, what is the oxidation state of X in the compound XKL? Okay. I think I didn't teach you this part. Oxidation numbers you have to do in group 3rd unit for the compounds. Normally, for the structures, we did oxidation number. When they give a structure, how to find the oxidation number, we did in unit 2 itself. But using a formula, how can we find KNK? Because for X KNK, you don't know. If you know X, at least you'd have done something. You don't know anything about X. Right? Therefore, you can't do this now. We have to complete unit 3, then you can do. Okay. But I will tell you on මෙතන I will explain how to find කියලා. මේ ලොකු scene එකක් නෙමෙයි. Now x2032 minus x2032 minus mean I will tell careful listen. Okay. Normally oxidation number of a neutral molecule is 0. The total oxidation number of neutral molecule is 0. For an example, if someone asks what is the CO2's oxidation number, entire CO2 molecule's oxidation state is 0. Okay, the total molecules, again, if it's a neutral one, neutral means now they don't have a charge. No, CO2 is a neutral one. Okay, what do you mean by neutral? They don't have a charge existing outside the molecule. You can't see a charge on the molecule, then that's neutral. What is a neutral? Again, most of the molecules, whatever we are writing, NO2 is neutral, CO2 neutral. Okay, likewise, you can tell the compounds, those are neutral. I thought those neutral total oxidation state is 0. But if there are charge on a molecule, okay, there is charge on a molecule means become ion. So if there are ions, right, those ions oxidation state is equal to that ion. Ions, how much is the charge? That will be equal to their charge. Now, for an example, this molecule's oxidation state now 2 minus. No? Therefore, this oxidation state should be equal to -2. Okay. Now I told oxidation state, right? That should be equal to -2. Okay. Right. This 2 minus it should be equal to -2. Then, children, we have to go for now these valencies. Now, what is oxygen valency? Oxygen's valency is 2. Now, what 2 we have to check? What 2? It is -2. Okay. Normally, oxygen, they will get 2 electrons. So that's why they become this one. They obtain 2 electrons. That's how we see the oxidation number. Normally, when we are using oxygen, it becomes -2. Now, think like that temporarily. So, 1 oxygen is -2 mean 3 oxygens will be how much? -6. It should be -6. Should be -6. It should be -6. If it -6 mean, to give -2 as the value, this x should be how much? +4. This x should be +4. If this x is +4, mean how many x are +4? 2x are +4. Then 1x should be how much? +2. That is +2. Then that's how you have to see this value. But right, this X2032 minus mean it's a very famous anion. Okay, that is actually you can say S2032 minus. This anion. But actually S2032 minus ions, sulfur is not in +2 oxidation state. The answer will come as +2. This is average oxidation state you will get here +2 කියන එක. But here, when you draw the structure, you will understand this is not like this. I will draw and show you. Now, these are some external, however, you will learn this. No? Therefore, I'm showing this. Now, S2032 minus KLI, when I give, you know how to draw it. How to draw it. One sulfur will be the central atom. Keep the sulfur as the central atom. Keep the sulfur as the central atom. Then you can start drawing. When sulfur is the central atom, you can connect one sulfur here. Then there will be 3 oxygens connecting here. You have to connect 3 oxygens surrounding this. Now there is only S2O3. Now 2 minus mean, I said if it oxygen ion, the minus charge should be on the oxygen. Then this oxygen will also get a double bond. Now I will show you the oxidation states. Now, when you draw the structure, now you know to find the oxidation states. Right. I will give you 1 minute. Now I gave you the idea how to find the oxidation state of the molecule. You have to find this sulfur's oxidation state. You have to find this sulfur's oxidation state. And I will give you a small time. That is your work. Give it a try. And put that in the chat box, right? What is your answer? Now, everyone, I gave you the idea how to check with the valency, with the oxidation state. Yeah. Can you put? Okay. Well done. Excellent. Your answer is correct. Only one child sent the answers over. Very good. Your answer is correct. Right. Okay, I'll explain that point. That's a good point. I'll explain that. Okay. Now here you can see this. Now you have to see the comparison of the what comparison of uh, this sulfur, sorry, this sulfur. Now, when you take this oxygen will be -1, this sulfur become +1. Alright. This oxygen become both the oxygen -2, both the oxygen become -2. So this sulfur become +2. Okay. Because of this oxygen, this become -1 and this sulfur become +1. Okay. Then this sulfur, see this sulfur. Now, in this sulfur, uh, it become, this become what? Now this become when relative to this sulfur is neutral. Again, they don't have a relative charge. Therefore, they don't get plus minus scale. We can't distribute them because both are the same atom. If they're the same atom, then we don't get anything from this. So you have to see add all these plus charges, then this sulfur become +4. Very good. Most of the students, they have sent this answer. And this sulfur become, they don't have any relative charges. No? That's therefore the sulfur's oxidation stuff become 0. So this should be the 100% correct answer. Again, one sulfur is in 0 and one sulfur is in +4. But according to this question, you have to go for +2 as the average one. Okay, because there are 0, 4, +2, everything is there. So they have expected the +2 in this, right? But if they have given the structure here clearly, it should be 1 is in +4. Like if there is a +4 answer, you have to go for that. That should be the best thing. If not 0, 0 sulfur also there. Okay, what is the oxidation state of X in the compound mean? Actually, they should give 3 answers for this. 0 also correct, +2 also correct, +4 also correct. +2 means the average oxidation state of both the sulfurs. One is in +1, one is 0, mean +2. Okay, average we are taking the oxidation state. There is a nice question from a student, okay, about the previous question. In the previous question, the doubt is like this. Okay. Now, normally I said they get a minus charge if they are lacking one bond. So that child's concept was, now if there is a minus charge, that means they are lacking one bond here. So it's supposed to be fourth group killer. There is an argument. Okay, good. But when we see the group, now if they ask what is the oxygen's group, oxygen valence is 2. But what is the oxygen's group here? Is the oxygen group is 2? No, no. How you check the oxygen's group? You can see around this oxygen, see how many electrons are there. How many electrons are there? 7 electrons. Out of 7, 1 is not belong to oxygen. Therefore, oxygen belong to which group? There are 6 electrons around oxygen, then oxygen should belong to 6 group. Again, 16 group. Okay. So see this fluorine. How many electrons are around fluorine? 7 electrons. Therefore, this fluorine should belong to 7th group. Same way, you have to see number of electrons around this to see the group. Number of bonds and number group mean both are two things. Is it clear? Charge is decided by the valency, not the group. Okay, good. Nice. Uh, okay. Now the next thing. Which of the following quantum number correctly represents the quantum number of valence electron of the atom with atomic number 37? Alright. Now atomic number 37 mean you have to write the electronic configuration to check that. Right? Okay. Write the necessary things. I hope write everything. Because when discussing questions only, your knowledge will be very thorough. Then only you'll get the confidence to answer all the questions. Right? Okay. Now children, see this part. Okay, this one. Now 37 mean, how can you write this? 1s2, 2s2, 2p6, okay. Then 3s2, okay. 3p6, okay. Then 3d, 4s, 4s2, 3d10. Then you can see 4, 10, 12, 18, 28, 30. 30, 36, no? 36, 4p6. After 4p6, it will be 5s1. Okay, after 4p6, it won't be 4d, no. It will go to 5s and only it will come for 4d. Okay, then it is 5s1 electron. So 5s1, how to decide? 5 mean 5 means this 5 means the main energy level. 5 mean the main energy level. Then all are 5, then that is okay. Then second one about the shape of the orbital. Shape of the orbital is S. For S, we give a number. We have numbers no, for the shape of the orbital. If it S, if it P, if it D, if it F mean we have numbers no. S mean we give 0. P mean we give 1. D mean we give 2. F mean we give 3. So in the quantum number, right, for this orbital shape, we give a number. Okay, this 0, 1, 2, 3, this is known as L කියලා. Quantum number L, azimuthal quantum number කියලා. So azimuthal quantum number decide the shape. Hare? So then 0, 1, 2, 3 කියලා we have. Then, so you can see here, you can write S එකට 0, we have to, second value should be 0. So 1 තියෙනවා, you can cancel. This is wrong. This option is wrong. This option is wrong. Why? This second value should be 0. So this is 0. After that, third thing, you have to say in this is known as the shape. No? In this, you have to say which orbital, like which orientation these shapes are there. S orbital can be there in only one orientation because they have only one, they can be in only one orientation. Therefore, for this one, we give a 0. ML eකට we give 0. Okay, so this, again, if there is only one box, for S having only one room like this in S orbital. P orbital, there are 3 ways of orientation. We give 3 rooms like this. So these rooms, we give a number. For middle one, we give 0. This one, we give 0. For left side, we give -1. For the right side, we give +1. Okay, we give numbers like this. Okay, so here, this will be what? Here, this will be 0. So answer is first one. Okay, 500 plus half. Okay. In case if you have forgotten the quantum number, no problem. You can get the recordings and see that. Okay, we can provide that. Right. That is a simple thing. Other things I said related to unit 3. These are all things related to unit 3 because it's a first term exam. So related to unit 3. So we can do the next one, question number 10. Okay. Following statements are stated related to orbital overlapping and hybridization. Correct statement in these. Okay. Now you know orbital hybridization happening when they are going to make bonds. So this hybridization will happen between the same atoms. Okay. Hybridization of the orbitals happening between the same atoms. Okay. So if I give you a summary on this, right? S orbitals, again, S orbitals, they can overlap only linear. So they will form a sigma bond. S orbital and p orbital also always can join in a linear way. So always between s orbital and p orbital, they will have a sigma bond. This is a sign for sigma. This is a sign of sigma. But two p orbitals, only two p orbitals mean they can join in linear way. Linear mean like this. This is a p orbital shape. It's like a butterfly. Okay, so they can join in the linear way. Then they will form a sigma bond. But the same p orbital, if they form in the lateral way like this, right, they will form a pi bond. Okay, so pi bond is formed only by lateral overlapping. Okay, so that is only formed by, okay, atomic p orbitals. Hybridized orbitals always form sigma bonds. So these rulings only the basic theory of the orbital overlapping and hybridization, right? So now let's see. Hybridized orbital can overlap only with hybridized orbital. Hybridized orbital can overlap with atomic orbital. That doesn't matter. So, okay. Atomic orbital can overlap only with atomic orbital. Atomic orbital can hybridize. They can overlap with hybridized orbital. Overlapping can occur between the orbitals of one atom. Between the same atom, overlapping can't happen. Definitely, it should be two atoms. Overlapping means one is going on another. Hybridization is happening between the same atom, but the overlapping is happening between two atoms. Pi bond is formed by the linear overlapping of two p orbitals. Just now I told you, linear overlapping always form sigma bonds. It will never form pi bonds in linear overlapping, right? So pi bond will never form in linear overlapping. It will form only in lateral overlapping of p atomic orbitals. Overlapping can occur between orbitals of different atoms. Okay, that is correct. Okay, overlapping can occur between orbitals of different atoms. That should be the correct answer. Fifth one. Okay, so this is easy. So this is the basic knowledge of orbital overlapping. Right. So this is the basic idea. Tagala write the necessary things. Okay. Always these several statements I told. Always sigma bonds form between the linear overlapping. Pi bond can be formed only by lateral overlapping of atomic orbitals, atomic p orbitals. Okay. Hybridized orbitals can never form pi bonds. Hybridized orbital will always form sigma bonds. And they are very important points. Tagala write those. Okay. Done. Wait, did you see the did you see the 26 A-level paper? Did you see the 26 A-level paper? Yeah, yeah. Okay, we'll try to do some questions. Are Then we'll try to do certain questions. Wait, we'll share. A-level students also playing with the screen. Are Stress. Give me a minute. I will share this A-level paper. This is one of our students' paper. Send me.
போனக்கா ஒரு அவசரத்துக்கு கோல் அடிக்கிறதுக்கு எடுத்தா
Mute your microphone.
ஆத்தி நல்ல பிள்ளையா இருந்தா
Mama,
தாங்க
your mama is shouting. Mute your microphone. Hmm. Okay. Right. Wait. I'll right. Now, okay. Okay. Now, see this. Now in this, this is a paper. Okay, this year's paper. We'll see how many questions you can try here again. Like I will give you. First of all, we'll finish that, and after that, we'll come here. Okay. Mm, now the next thing, 12th one, incorrect statement regarding hydrogen atomic spectrum. First one, the energy difference between levels N2 and N1 is greater than the energy difference between levels N3 and N2. Now, you have to draw and see here different levels of the hydrogen spectrum. If you draw the different levels of hydrogen spectrum, now we'll say from first level to second level, this much of energy gap here. Then when you're going for top energy levels, the gap between the energy level will reduce like this. The gap between the energy level will reduce like this. Okay, the gap between the energy level will reduce like this. Alright. So we'll say this is the first energy level, this is the second energy level, here third, here fourth, here fifth, like by 5 energy levels. First one is the energy difference between energy levels N2 to N1. N2 to N1 energy difference is this. Alright. Then other one N2 to N. Other thing what they have given here is greater than the energy difference between N3 to N2. N3 to N2 mean this N. So they have said the energy difference between energy level N2 to N1 is greater than the energy difference between the N3 to N2. Right? That is true. Then the energy corresponding to the lowest wavelength line of Lyman series is the first ionization enthalpy of hydrogen. Okay. Then the energy correspond to the lowest wavelength. Lowest wavelength should have the highest frequency. No? Lowest wavelength should be the highest frequency. So the lowest wavelength of the Lyman series will come from infinity. Okay, from whatever, again, lowest wavelength means the highest frequency. So it is go like this. There are so many energy levels till infinity. Right? And infinity, then lowest wavelength should come from where? From the infinity. So infinity first energy level. So what is first ionization energy means? First ionization energy means you're removing an electron from the hydrogen. Hydrogen first ionization energy means, right? You are removing the electron from hydrogen. Removing electron mean what? Electron will completely go away from the hydrogen. We'll see if it go to first to second, fourth level electron when it's excited, if it go to upper levels, when it falls down, it is not going away from the hydrogen. However, it will be in the limitation of the hydrogen. But first ionization energy mean what? They are removing the electron completely. It means hydrogen is going to lose the electron. Right? When hydrogen is losing the electron, that goes out of the board. The Lyman series energy corresponding to the lowest wavelength of the Lyman series is the first ionization enthalpy of hydrogen mean. That is true. Okay, because that's shortest wavelength is from the infinity. The lines of ultraviolet region of spectrum is obtained when the electron transit from greater than N2 energy level to N1 energy level. Ultraviolet region, that is true. Okay, so UV region is Lyman series. If any from any level, if it comes to first one, we say Lyman series. From any level, if it comes to second one, we say Balmer. Third nang Partian. Fourth nang bracket. Fifth nang Fun series. Alright, nice. Then the fourth one. The violet color line of visible region is obtained by the electron transition from N5 to N2 energy level. Violet color. Violet color mean from second level only visible light region. So violet is having the highest frequency. So N5 to N2 is violet. Okay, N3 to N2, N4 to N2. Okay, N3 to N2 will have a color. N4 to N2 will have a color. Then N5 to N2 will have a color. Okay. So what are the four colors I gave? N6 to N2 there will be a color. N6 to N2 also there will be a color. 3 to 2, 4 to 2, 5 to 2, 6 to 2. So what are the colors? Blue, green, red. Okay. Red, green, blue, violet. Okay. These are the four colors you will observe in the hydrogen spectrum. Red, green, blue, violet. Okay, so red will have the shortest one, then green, then blue, then violet. So violet is which one? From N6 to N2. Hurry. Then each line of the spectrum directly related with the energy value of the particular energy level. Okay. Each line of the spectrum directly related with the energy value of the particular energy level. So these lines shows what, right? What type of we first of all draw this. Draw colors ටික mark කරන්න. Although you know still draw that. Okay, done. Alright. Now see this. Now the next one is each line of the spectrum directly related with the energy value of the particular energy level. Okay, now spectrum mean though this is the how spectrum occurs. But how you see the spectrum as a lines like this. Okay, in emission spectrum, you will see the lines like this. Now we have lines sticker, you will see like this. What are these lines actually? These lines means, for an example, this line mean from here to here, if there is an energy level, this the energy needed from second energy to first energy. Whatever energy needed to second energy represented by this line. So here what is represented by this line is not the energy level, right? It represents the energy difference. Remember that. In a hydrogen spectrum, it represents energy difference. Okay, not the energy level. Okay, energy difference. Okay, mark that. Okay, right. From each line of the hydrogen spectrum, it shows the energy difference, not the energy level. Okay, it shows the energy difference. Right. It doesn't show the energy level, it shows the energy difference. Right. And okay, now which one is the most wrong answer? The method there is a thing like this. Sometimes green, blue, natur. If they give 3 lines, they will take this as red, blue, violet. Or sometimes are certain places. Second to third to second is red. Fourth to second is blue. Blue they will take as blue. 5 to second violet කියලා certain places they can take. I think our most strong one we have to take the fifth one because fifth is absolute wrong. This is just a color. This color chuttak can be differ, right, with the energy level. When there is a question, they'll go for the most strong one. But if they have given N3 to N2 gives violet, now that is absolutely wrong. But violet from N5 to N2 also could occur, N6 to N2 also could occur. Right? I think it depends on the other statements only. You have to select that. We'll say all the other statements are absolute truth means then you have to go for the fourth one as the answer. Now, when you compare fourth and fifth one is the most strong one, right? Because in A levels, you get like this. So you can sometimes we learn like this, but chuttak adjustable. You should be adjustable in certain areas. Good. So clear? Nice. So that is done. Right. Then next thing, this 14, 15, everything related to this. Now 16th one. This ABCD related statements, guys, this is how you have to answer. If A and B are correct, option 1 you have to go. B and C mean second one. C and D mean you have to go for third one. D and A is correct mean you have to go for fourth one. Any other numbers now, you have to go for fifth one. Now, which of the following can be the reason for the strengthening of a metallic bond? Metallic bond, remember, metallic bond strength depend on two factors. One is size. If the size is small, because metallic, what is a metallic bond? Metallic bond mean it is a bond, okay, where you have these metal ions. These metal ions are packed here like this, and there are electrons in between. So this is electrostatic attraction. Metallic bond means electrostatic attraction between these positive charges and electron, because there is like a pool. So we say they are surrounded in electron pool. There's electron pool there, so metal ions are in that. Okay, so there is a positive nucleus in the metal. Therefore, this electron pool avoids the repulsion of this. Okay, so this strength increases when the unit charge, can if the charge density mean charge density in a unit volume increases, mean their metallic strength will increase. Okay, their metallic strength will increase. So when the charge in a unit volume will increase, if the sizes of the ions, if the size of these metallic, whatever the metallic ions, if it small, then the density will increase. Other thing is when they contribute lots of electron to the pool, right? When they contribute lots of electron to the pool, their charge density will increase. So these are the two factors how the charge density will increase. So then with this, what will happen? Metallic bond strength will increase. So answer is first one, decreasing metallic radius mean that is true. If this metallic radius decreases only, what will happen? The bond strength will increase, metallic bonds. Decrease the number of free electrons. Free electrons, when it decreases, when it increases only, metallic bond will increase. Then decrease the charge of metallic cation. Decrease the charge, so both are same thing. Increase the charge. Decrease the atomic radius. Here, atomic radius is not involvement, metallic radius only involvement. The metallic bond, metallic radius, not the atomic radius. Because atomic radius, again, when you take the sodium gas atom, right, we can't exactly define a boundary for them. So these metal ions, when they are metals only, we can define a radius for that. So the answer is only A is correct. We have to go for this. Then fifth option, we can go here. Only A is correct now. Fifth option. 17th one, chemical calculation. 18th one, from which of the following the information about the electron structure in atom obtained? I gave this. Okay, I gave this question already. Alpha scattering experiment. That from that you found the positive charge, not about the electron structure they have asked. Data is about ionization energy. From that you can find the electron structure. Spectrum researchers using the spectrum, because different element have different type of spectrum. From that you can see how many electrons are there, right? Their valency, everything you can find using that. Cathode ray experiment, you can't find, because there you can see only about electrons qualities there. Cathode ray experiments, you can find the electrons qualities, not about the electron structure. Electron structure mean in an atom how the electrons, how many electrons are there, how many valence electrons are there, how many co-electrons are there. Even cathode ray experiment you can't find. The answer should be B and C. Then second one you have to go. Hurry. Home now we'll go for 26 level paper. We'll see. We'll go and we'll see whether you can get the answer for the first one. First and second. මෙන්න මේ දෙක ටක් ගාලා you write your answer. මෙතනත් answer එකක් තියෙනවා. but ඒව හරියද දන්නෙත් නැහැ. You find the answer for the 1, 2, 3. Maybe Tunatama try to get the answer. 1, 2, 3. 1, 2, 3. First of all, select. After that, I will discuss this. What interest? Did you try this paper? No, no. Cover try kara already. I try all the questions, whatever you can. You can try all 3 questions from unit 1 and 2. You itself can try freshers. Taggala, give an answer. ඔගල ආන්සර්ස් ටික chat box එකේ දාමු අපි හරිද? I didn't get the answers yet. Only one answer so far. Others also give a try. Good. Mhm. Yeah. Can't see. Can you? Can't you see the screen? The this year's latest hot papers, plus three questions. Here you can do up to first four in a you can. There are questions you can do. I'll give you. Okay. Okay. Now let's discuss. Hari. Now first one is very easy. No? What is a Barmer series killer they have asked? You know, first, if any from any level, if it come for first nang, that is Lyman. From any level, if it come for second one nang, it is Barmer. Right? So which one should be the correct one then? From any level above 2. So second one is Barmer, so should be fourth one. Okay, the first answer is fourth one. Okay, so this is correct. Whatever marked is correct. Okay, it should be fourth one. That is from any level above 2, it should come to the second one. Alright. Then the next one. The outermost p electrons of a nitrogen atom in a ground state can be denoted by the quantum numbers N2 and L1. Outermost p electrons. So you know nitrogen when you take, this is the configuration 1s2, 2s2, 2p3. Here it is marked here as it is. So in that, when you take the p energy level, these are the three electrons. So this is the first electron, this is the second electron. Okay, these are the outermost two electrons. So when you take the first electron here, what is the quantum number of this? So this belongs to second energy level. So should be 2. They are asking the ml and ms only. So ml here, this ml is 0. This ml is plus 1. So ml 0 and ml plus 1, we have two answers here, ml 0, ml plus 1. So likewise, we have only one answer. That is third one. These are the two outermost electrons, Ml0 and Ml plus 1. So answer is third one. So this one also correct. Okay. Now the next one. They have asked, consider the species Cl minus, argon, and potassium plus. Which statement is true regarding these species here? They have asked. Chlorine is 17th. Argon mean it is 18th. Potassium mean it is 19th. Right? So here they have a Cl minus. Can you see there is a minus here? It is Cl minus. Huh? You took it as Cl minus, people? Or you took it as Cl? What did you take? Cl minus or Cl? It's Cl minus, okay? If you have taken as chlorine, Cl minus now, okay. If you have taken as chlorine, you can recheck your answers. So this one Cl minus mean what will happen? Chlorine is having 17 electron, so it will also will have 18 electron. Argon also will have 18 electron. Potassium plus mean, K plus mean they will lose 1 electron. So from 19 electron, they will also have 18 electron. They have the same atomic mass. They don't have same mass, no. Chlorine mass is different, argon is different, potassium is different. Their first one is wrong. They have the same atomic radius. Do they have the same radius? Cl minus, Cl minus is larger than argon. Potassium plus is smaller than Cl minus. Then they have same atomic radius කියන එක, that is false. They don't have same. They have the same atomic number. Atomic number, is it same? Atomic number is different. These electrons are same, but atomic number decided by number of protons, no children. The chlorine is 17th element, its atomic number is 17. Although it's a minus charge, chlorine is atomic number is 17. Argon is 18, potassium is 19. Atomic number same කියන එකත් wrong. The effective nuclear charge fell by an outermost electron of each species is the same. That also wrong, no? Because Cl minus is larger, then the outermost electron will feel less nuclear attraction. Okay, the less nuclear charge. Potassium plus is small, therefore potassium's valence electrons will feel a more nuclear charge. Those also can't be same because that is also wrong. They have the same number of p electrons. All are having 18 electrons, and p electrons mean what? The number of electrons in the p. So all are having 18 configuration now. They are having 1s2. Now the electronic configuration of all of these elements will be 1s2, 2s2, 2p, 6, 3s2, and 3p6. So what will happen here? All of these people having same number of p electrons. It means they have 6 electrons. So answer is fifth. Okay, they have the same number of p electrons. That is true. So you have to go with that. Okay. Now the fourth one. Which of the following statements is false with regard to xenon and its compounds? Aneka, I didn't ask you to do it. Aneka, you can do no. Give a try. Fourth one. Okay. And put your answers in the chat box. Please put the answer in the chat box. Select wisely. Right. Now they have asked first one, which of the following statement is false with regard to xenon and its compounds? First one, they have xenon has the highest boiling point among the element helium to xenon. You guys know this is 18 group element: helium, neon, argon, krypton, and xenon. So you know when you're going down the group, what will happen? Atomic size increases. Okay, now this one you have to answer with the secondary interaction, what we have learned in our class. When you're going down the group, atomic size increases. And also, there are London forces. Okay, what is the force among these things? London forces. Therefore, London forces increases. When the London forces increases, what will happen? Their melting point and boiling point increases. Therefore, Shannon has the highest boiling point among these group in the 18th period. That is true. This one is true. Second one, Shannon has the highest first ionization energy among the group 18 elements. You know, when going down the group, what happened to the first ionization energy? You know what happened to the ionization energy. What do you mean by ionization energy? Ionization energy means the energy needed to remove the electron. The energy needed to remove the electron. So now we'll say when you're going down the group, what happened to the radius? Radius become large. Radius become large. When radius becoming large, the ability to remove the electron, what will happen? Increase or decrease? Reply. The ability to remove the electron will increase or decrease. The energy needed to remove the electron will increase or decrease. The energy needed to remove the electron will increase or decrease. When you're away from the nucleus, the nuclear attraction will reduce. Therefore, the energy needed to remove that electron also will reduce. Therefore, when going down the group, when you're going down the group of any period, okay, first ionization energy will reduce because the radius become large. Therefore, energy needed to remove that electron will reduce, children. Okay, the energy needed to remove the electron will reduce. Therefore, easily you can remove the electron. Therefore, Xenon has the highest first ionization energy among the group 18 elements of the first periodic table. That is false. That statement is false, right? Because xenon should have the least first ionization energy. It should have the least first ionization energy. The energy needed to remove the electron only. Ionization energy means okay, how much energy you have to supply to remove this electron. The oxidation numbers of xenon in XCF4 and XCF6 plus 4 and plus 6 respectively. That is true. No? So fluorine is F4 mean. What is XCF4? I'll draw this. I'll draw and show you. I just wanted to give you this paper because it's very new paper, ne? Freshly cooked paper. So XCF4 mean this XCF4. Right, XCF4. Then what I said, how is the oxidation state? This get a -1, this get a +1. So likewise for all three things. So this xenon is +4. Then XCF2 mean if they have two fluorines now. Sorry, XCF6 now there are 6 fluorines now. +1 +6 means that is true. XCF2 shows a trigonal bipyramidal electron pair geometry. Okay, XCF2 mean this one. XCF2 mean this one connect with fluorine. Now mark the lone pairs. Xenon is 8th group. No? Then if you mark the lone pairs, 1, 2, 3, 4, 5. 5 mean electron pair geometries, VAC pair units 5. No? VAC pair units mean sigma bonds and the lone pairs. So method 5 units now. That is trigonal bipyramid. That is true. Okay, XCF2 shows trigonal bipyramid. That is true. The atomic radius of xenon is the highest among the 5 elements. Yeah, when you're going down the group, the radius increases. So the strong one is second one. Second one we have to. The people who have selected second one, excellent. Right, good. Okay. Is it clear, children? Okay, actually this paper is easy. Right, if you know the concepts, easily you can answer. It's not difficult. Like Nikan like most of the these graph, this graph actually I did this also I did on August 1st. Okay, not only that graph, even this graph I did 1st of August. This graph I did. Okay, this graph I did on August 1st. Almost like everything we did. Okay, then actually this graph also I did before the paper. Okay, so almost we did everything, and the second part also there. Second part you can answer any questions later. Paper 2 I have structured I don't have. Right. Anyhow, this is the paper. I hope you would have got some idea. තව එකක් you can do. Wait, I'll show this question you can do. එතනයක් තිබ්බ මේ you can do only one more question. The CLO minus sign, there was a question. This one, 12th one. Hmm. You can try the 12th one. Give me an answer for the 12th one. Give a try to get the correct answer. Right. Now let's discuss this. the Lewis dot dash structures of ClO2 minus, ClO3 minus, and ClO4 minus contain 1, 2, and 3 oxygen chlorine double bond respectively. First of all, we'll draw these ions. We have draw ClO2 minus, ClO3 minus, ClO4 minus, and also ClO minus ions to do this question. Now, you know, these all oxygen ions. No? Now, earlier also in the previous paper, we found oxygen ion. So I told a pattern how to draw this. Okay. Chlorine, ClO2 minus mean just connect chlorine with two oxygens. Then I said the minus charge should be on the oxygen here. Then put the one minus charge on oxygen, other oxygen, you connect with their valency. Then fill the other electrons. 1, 2, 3, 4, 5, 6, 7. Because around chlorine, there should be 7 electrons. Now I am mainly focusing on the electrons on chlorine. No? Okay, but you have to do the chlorines electrons on oxygen also. But here, then ClO3 minus mean chlorine with 3 oxygens. Then minus should be on the oxygen. Then this oxygen should connect with double bond. This also should be connected with double bond. Then 1, 2, 3, 4, 5, 6, 7. Then if I want to draw ClO4 minus, chlorine with 4 oxygen. 1, 2, 3, 4. Chlorine with 4 oxygens mean I have to connect double bond here. Sorry, minus charge if I put here, all the other things will be double bond. Right? Then ClO minus mean chlorine with only one oxygen. Then that minus charge should be on this oxygen. 1, 2, 3, 4, 5, 6, 7. These are the electrons should be on chlorine. Now the thing is, you can see the Lewis dot dash structures contain 1, 2, and 3 oxygen chlorine double bonds respectively. You can see in ClO2 minus only one double bond, here two double bonds, here you have three double bonds. So that is true. The oxidation number of chlorine plus 3, plus 5, plus 7 respectively. So you can see this given by 7 bonds, so oxygen plus 7. This is 3 bonds, so this is plus 3. This is altogether 1, 2, 3, 4, 5 bonds, so chlorine is plus 5. And that is also true. ClO2 minus has an angular shape. ClO2 minus this one. So if you know about the shapes, you know this is angular shape. That is also true. The structure of ClO minus contains an OCl double bond. So you can see they don't have OCl double bond. They have only OCl single bond. So the false one is fourth one. The electron pair geometry around Cl in ClO3 minus is tetrahedral. Yeah, you can see this. There are 4 sigma bonds. That is tetrahedral. So most of the students they have given the fourth answer. Well done. Right? Okay. Superb. So you also can do this. Okay. Now you also have the knowledge. Okay. So wouldn't XCF2 cause linear geometry? No, no. The XCF2 has linear shape. The shape of the molecule is linear. Geometry of the molecule mean you have to see only the VSCPR units. Total VSCPR units, you give the main shape. Okay. Geometrical, this geometry around the central atom killer we learned. Okay. That is a trigonal bipyramid. Okay. Is it clear, everyone? Right. So only these things you can do. You can't do any other things. I want a small thing from your side, Hari. Okay, how was today's session? Right. So could you explain one more the first statement on the fourth question? First statement on the fourth question. Fourth question. First statement. Xenon has the highest boiling point. That because when you're going down the group, I explained in the last class. In the London forces, when you're going London forces, when the size and the mass increases, London forces strength increases. When the London force strength increases, okay, you have to give more energy to break these bonds. Okay, boiling point mean not liquid to make it gas. You have to give more energy to make that liquid to gas. Therefore, when you're going down the group, boiling point and melting point increases due to London force increases. Clear? Right. Okay. Now, before you leave, please comment here in the chat box. How was today's session for you? Right now, it was an online session. So, how was it? Did you understand how much it is useful? The explanation, everything you can give. Okay. If there are anything to improve, you can mention that one also in the chat box. Yeah.